What is sonar?
Sonar, an acronym for sound navigation ranging, is a method of using sound waves to determine the distance an object is from a transmitter of sound. The sonar contains a transducer that converts an electrical impulse to sound. When it transmits, and a sound wave to an electrical impulse when it receives. Sound waves, usually brief pulses of ultrasound, are emitted from the transducer, reflected off an object, and reflected back to the transducer. Electronic circuits measure the length of time it took for the sound wave's round trip, and use the speed of sound to calculate the distance the object is from the transducer. Sonar is used predominantly as a navigational tool by humans and animals. Dolphins and bats, among other animals, use sonar for navigation, hunting, and communicating. Machines such as depth finders on boats, distance meters used in real estate and construction, and motion detectors for security devices all employ sonar.
What is transparent?
Media that allows light to pass through the material. Rays of light are either not bent, or closely spaced rays are bent together.
On what does the gravitational field, like that of Earth, depend?
Newton demonstrated that the gravitational force on one object caused by another is proportional to the product of the masses of the two objects divided by the square of the distance between them. The gravitational field of an object would then be the force divided by the mass of the object on which the force is exerted. The symbol used for the gravitational field is g, and g is the so-called universal gravitational constant. It is called universal because it is the same for objects made of any material and of any mass, from a 1 kilogram apple to a galaxy. The equation that describes the gravitational field at a specific location is G equals gm/r2, where m is the mass of the attracting object and r is the distance from the center of this mass to the location in space. The gravitational field is a vector quantity. Its direction is toward the center of the attracting object. Well, consider its magnitude shortly.
Does my neighbor's motorcycle have to be that loud?
Times, engineers try to achieve just the right sound or noise for a particular product. The product, whether it's a vacuum cleaner, lawnmower, or motorcycle, needs to be quiet enough so as not to cause stress, yet has to have enough sound to seem powerful. For example, muffler technology has the ability to greatly reduce the noise a motorcycle produces. Yet many engineers and manufacturers feel that consumers would not purchase the product if it does not sound powerful enough.
What is white noise?
Roughly equal sound intensities at all frequencies.
What is a light year?
Distance that light travels in 1 year. 9.4605 x 1012 kilometers, or about 6 trillion miles.
How do the speed and position of a dropped object vary with time?
As long as the only force is the gravitational force, then the acceleration is the acceleration due to gravity, g. At Earth's surface the value is 9.8 meters per square second. In the English system g equals 32.2 feet/s2. If the object is dropped from rest at time t equals 0, then the velocity at a future time t is simply v equals gt. That is, the velocity increases by 9.8 m/s each second. If we measure the distance fallen from the position where it was dropped, then at time t it has fallen a distance d equals 1/2 gt2. The following table shows velocity and distance fallen for some selected times.
How did a fogged film start a revolution?
In 1896 the French physicist Henri Becquerel, 1852–1908, was exploring the properties of a compound of uranium that glowed in the dark. He placed the compound in a dark drawer on top of a photographic plate that he had wrapped with heavy black paper to make it light-tight. The next morning he was surprised to find that the film was already exposed, or fogged. Becquerel presumed that some unknown rays had been emitted by the uranium compound, gone through the paper, and created the same chemical reaction in the plate that light would. In further experiments he found that a thin piece of metal would block the rays. It was soon alpha, beta, and gammas all are hazardous to our health. Alphas are blocked by skin, but if a radioactive material, such as the gas radium, is inhaled, the alpha particles can cause damage to the lungs. Betas can penetrate skin and tissue and, if they strike a cell, can cause mutations to the DNA. Gammas can cause mutations and kill cells. They are used in cancer radiation therapy.
What is an insulator, electrical?
A material in which electrons are strongly bound to their nuclei and thus cannot move through the material.
If this were the case, wouldn't riding a bicycle do the same thing?
The real reason why a car is a safe place to be when struck by lightning is because most cars have metal bodies, which act as Faraday cages, keeping all the electrical charge on the outside of the car. Since the charge is kept on the outside of the vehicle, the person sitting inside the car is kept perfectly neutral and safe. It is the shielding of the metal car body, and not the rubber tires, that protects people in automobiles.
What is Kepler's first law?
Planetary orbit is an ellipse with the Sun at one focus.
What is frequency modulation, FM?
M-wave frequency changes to represent transmitted information.
What is the middle ear?
Between outer and inner ear. Includes the eardrum, the hammer, anvil, and stirrup. The three smallest bones in the human body, and the oval window on the inner ear.
What is the reverberation time?
Time for a sound to diminish by a factor of 60 dB, that is, to 1/1,000,000 th of its original intensity.
What is a kilowatt, kW?
(1,000 watts or 1,000 joules per second).
How does one become a physicist?
The first requirement to be a physicist is to have an inquisitive mind. Albert Einstein, 1879 to 1955, himself admitted, "I'm like a child. I always ask the simplest questions." It seems as though the simplest questions always appear to be the most difficult to answer. These days, becoming a physicist requires quite a bit of schooling along with that inquisitive mind. In high school, a strong academic background including mathematics, English, and science is necessary in order to enter college with a strong knowledge base. Once you are a physics major in college, you will take courses such as classical mechanics, electricity and magnetism, optics, thermodynamics, modern physics, and calculus in order to obtain a bachelor's degree. To become a research physicist, an advanced degree is required. This means attending graduate school, performing research, writing a thesis, and eventually obtaining a PhD, Doctor of Philosophy.
What is overtone?
Mode of vibration R is not a whole number multiple of the fundamental frequency.
Have you ever seen the bed of nails demonstration?
A large number of nails are pounded into a board that is about the size of a person's back. The person very carefully lies on the bed. Sometimes a second bed is placed on his chest. A concrete block is put on this bed and a sledgehammer is used to shatter the block. The person is not harmed.
What is the plum pudding model?
Swarm of electrons in a positively charged sphere.
Why did Einstein win a Nobel Prize for the photoelectric effect, but not for relativity?
Einstein was a controversial person. He was Jewish and a strong supporter of pacifist causes. In addition, his approach to theoretical physics was very different from physicists of that time. He was repeatedly nominated for the Nobel Prize, but members of the prize committee, despite his public fame, refused to grant him the prize. Most likely for political reasons. The 1921 prize was not awarded. In 1922 the committee found a way to compromise. Einstein was awarded the 1921 prize for the photoelectric effect because of the way it could be tested experimentally.
What is an inelastic confinement?
In a collision, the kinetic energy of colliding objects is smaller after the collision than before it.
What is gravitational mass?
Mass defined by the effect of gravity on object. Gravitational force divided by gravitational field strength, m equals F gravitation/g.
Why do water waves break as they approach the beach?
Water waves rarely break, or form whitecaps. When they come in contact with a cliff or mountainside shoreline. Waves only break as they approach a gradual decrease in depths, such as a beach. A shoreline with a gradual decrease in depth will produce more spectacular whitecaps than a wave that encounters a steep decrease in depth. The reason waves break is the result of the way the wave velocity depends on the depth of the water. Consider a water wave with a large amplitude. As the wave moves toward the beach, At first it travels at a constant velocity. As the ocean depth begins to decrease, the bottom of the wave gradually encounters more and more friction with the beach, causing the lower part of the wave to travel slower than the upper part. As the lower part slows down, the crest, moving faster, moves over the trough. When there is not enough water to support the crest, the wave breaks or forms a whitecap.
Why is it often cooler to wear white clothes, rather than black clothes?
White surfaces reflect all the colors of the rainbow, whereas black absorbs all the colors in the light spectrum. The absorption of this energy heats the black material, increasing its temperature. This, in turn, increases the temperature of the air between the clothing and the person. So white, which absorbs much less radiative energy from the sun, is cooler in hot climates.
What is a shadow?
Areas of darkness created by an opaque object blocking light.
What is a stimulated emission?
Atom in excited state struck by photon with correct energy is stimulated. To emit another photon with same energy and drop to lower energy level.
What are the sources and uses of energy in the United States?
The tables below explain how much energy the United States uses per source and where the energy is used. The United States used 99.2 quads of energy in 2009, where each quad equals 1000 billion BTUs. Electrical generation, 39.97 quads, is very inefficient. Only 31.5% of the energy from the source, coal, natural gas, oil, nuclear, is transformed into electrical energy. The transportation industry is also wasteful in terms of energy. With 75% of the energy, mostly petroleum, it uses being wasted as heat.
How is temperature measured?
Temperature is measured by a device called a thermometer. There are many different kinds of thermometers, but they all have a property that depends on temperature. The most common type of thermometer contains a thin column of liquid in a glass tube. When the temperature goes up, the liquid expands, and the height of the column increases. Earlier thermometers used mercury, a metal that is a liquid at room temperature. Because mercury is poisonous, all thermometers sold today contain red-colored alcohol. The glass tube has markings on it from which the temperature can be read. Many thermometers today are electronic. Most contain a tiny bead of a semiconducting material whose resistance varies with temperature. The bead is called a thermistor, or thermal resistor. Others contain a tiny semiconducting diode. The voltage across this diode varies with temperature. To measure very high temperatures, a wire made of the metal platinum is used because its resistance also varies with temperature, and platinum is not affected by high temperatures. Another electronic thermometer uses two wires made of different materials that are welded together. Typically the wires are made of copper and a nickel-containing alloy. This kind of thermometer is called a thermocouple and is often used in gas furnaces or water heaters to make sure that the pilot flame is burning when the gas to the main burners is turned on. Voltage and resistance will be discussed later in this book. A less accurate, but convenient thermometer is a strip of plastic whose color changes with temperature. The plastic contains liquid crystals. The geometric arrangement of molecules in the crystals depends on temperature, and so does their color. If two different metals are bonded together in a strip, when the temperature changes, the strip will bend. Because there are two metals, often brass and steel, the device is called a bimetallic strip. This kind of thermometer is often used in household thermostats. This thermometer is similar to one developed by Galileo. The objects inside the tube have varying densities that rise or fall, depending on the temperature.
How is antimatter used in medicine?
A three-dimensional image that shows biological activity in a person can be made using PET or positron emission tomography. PET uses a short-lived positron-emitting isotope, typically 11C, 13N, 15O, or 18F. The isotope is chemically attached to a molecule that is involved in the activity that is to be studied. Fluid containing that molecule is injected into the person, and after enough time passes for the molecule to reach its target, the person is put into the PET machine. The positron that is emitted by the decaying nucleus strikes an electron and decays into two gammas that are simultaneously emitted back to back, that is, 180 degrees apart. Detectors record the arrival of the two gammas, and computers extrapolate them back to the location of the gamma emission. When a sufficient number of events are recorded, a three-dimensional image of the region where the biologically active molecule accumulated can be made. PET scans can be combined with CT or MRI scans to pair information on the anatomy with biological activity for diagnostic purposes.
What is the Snell's law of refraction?
Describes how light behaves at a boundary between two different media.
What is a monopole?
Isolated north or south poles. Predicted by some theories, but never found.
What is a watt, W?
Unit of power. 1 watt is 1 joule, J, per second, S.
What is a penumbra?
Area of a shadow where light from only part of the source is blocked.
What was the first type of bridge?
The first type of bridge ever used was a beam bridge. This bridge was probably just a fallen tree that was used to cross a ravine or a small stream. The tree was probably supported by the riverbed or by a group of rocks. Beam bridges consist of a horizontal roadbed supported by vertical piers on the shores that are planted in the ground. Beam bridges are limited by the resistance of the roadbed to bending.
How are neutrinos detected?
Neutrinos hardly interact at all with matter. Some 100 trillion pass through your body every second. Yet the chance that one interacts in your body over your lifetime is only 1 in 4. For this reason neutrino detectors must be huge and can expect to detect only an extremely small fraction of the neutrinos striking them. Most detectors are large cavities filled with extremely pure water or mineral oil. Neutrino interactions result in flashes of light that are seen by sensitive phototubes. The detectors have identified neutrinos from the Sun, from cosmic rays, a supernova, and from reactors and particle detectors. Some experiments have used beams of neutrinos that are aimed through Earth by a reactor or accelerator at a distant detector.
What limits have been established to reduce exposure to noise pollution?
The World Health Organization has recommended that noise during sleep be limited to a level of 35 decibels. And governments are beginning to place restrictions on noise levels in both residential and business environments. In the Netherlands, for example, regulations specify that new homes may not be built in areas of high noise levels, those that exceed average noise levels of 50 decibels. In the United States, employers must provide hearing protection for those who endure noise levels of 90 decibels for more than 8 hours a day.
What is the refractive index, n?
Ratio of speed of light in a vacuum to that in a medium.
What is Newton's second law?
If a net force acts on an object, it will accelerate in the direction of the force. The acceleration will be directly proportional to the net force and inversely proportional to the mass. That is, A equals Fnet/m or Fnet equals ma.
What is quantum teleportation and how does it use entanglement?
First, what it is not. It is not beam me up, Scotty, where a person disappears at one place and appears at another. It involves only information transfer by either photons or atoms. Teleportation involves an atom whose state is to be communicated from a sender, Alice, to a receiver, Bob. It also involves a source of two entangled photons. Alice first sets or measures the state of the atom. This is the information she will send to Bob. At the same time she measures the polarization of one of the two photons. This polarization information is the encryption key that will allow Bob to decode the information. Because the two photons are entangled, the polarization of the transmitted photon is fixed. Bob now has the key that allows him to decode the information Alice sent. In practice, of course, the encryption key isn't the polarization of a single photon, but many. The longest distance information has been teleported is 16 kilometers through the air in Beijing.
Why shouldn't you stand under a large tree during a thunderstorm?
During thunderstorms, many people stand under trees in an effort to stay dry. However, this can have dire consequences. In the spring of 1991, a lacrosse game at a Washington, D.C. high school was postponed after lightning was observed in the sky. Over a dozen spectators ran for shelter under a tall tree to protect themselves from the rain. A few seconds later, lightning struck the tree, injuring 22 people and killing a 15-year-old student.
What is the sound barrier?
The sound barrier is the speed that an object must travel to exceed the speed of sound. The speed of sound is often used as a reference with which to measure the velocity of an aircraft. The speed of sound, 331 meters per second at 0 degrees Celsius, is Mach 1. Twice the speed of sound is Mach 2, 3 times the speed of sound is Mach 3, and so on.
How is a camera similar to, and different from, the eye?
A camera performs many of the functions of the eye. It has a lens to form an image on a photosensitive surface. The lens must be able to form sharp images of objects both close and far away. The amount of light reaching the photo detector must be controlled to make the exposure correct. In older cameras, the photosensitive surface was film. Today cameras use a digital sensor. These sensors are small, most are between 3/8 and 1 in size, but contain as many as 10 million separate light detectors called pixels. Each pixel is covered by a red, green, or blue color filter so the camera can produce full color images. A camera's lens isn't flexible like the one in the eye, but the distance between the lens and the sensor can be varied. Bringing a distant object into focus requires that the lens be closer to the sensor. A close object requires that the lens be moved further away. The amount of light is controlled two ways. One is to have an aperture that can be opened to admit more light, or closed down to reduce the amount of light. The second is a shutter that controls the amount of time light is allowed to reach the sensor, while leaving the sensor exposed for a longer amount of time is needed when the light is dim. It also will cause a blurred image if the object is moving. Thus it is important to select the correct combination of aperture and shutter speed to take good pictures.
What's the strength of the gravitational field of Earth?
Earth's mass is 5.9736 x 1024 kilograms and the gravitational constant is 6.673 x 10 to 11 nm 2 kg2. At the surface of Earth, 6.4 x 106 m from the center, then g equals 9.8 n/kg. Thus a kilogram of meat, for example, experiences a gravitational force of 9.8 n toward Earth's center. Earth is huge.
What is reverberation time?
The reverberation time for a sound is the time it takes for the echoing sound to diminish by a factor of 60 decibels, that is, to 1/1,000,000 of its original intensity. The longer the reverberation time, the more echoing is heard because the sound has reflected off walls and other surfaces. The shorter the reverberation time, the less echo is heard.
What is a parallel circuit?
Circuit allows the charges to flow through different branches.
What is an ultrasound?
a method of looking inside a person's body to examine tissue and liquid-based organs and systems without physically entering the body.
What is an elastic potential energy?
The energy in the squeezed spring or stretched band.
How close can an object be before it appears blurry?
There is a limit as to how close an object can be to the eye before the lens can no longer adjust its focus. Up to about 30 years of age. The closest an object can be focused is approximately 10 to 20 centimeters, 4 to 8 inches. As one grows older, the lens tends to stiffen and it becomes more difficult for the person to focus on close objects. In fact, by the time a person reaches the age of 70, their eyes cannot focus on objects within several meters of their eyes. As a result, most aging adults need reading glasses to focus on close objects.
What are the primary colors from a light source?
When mixing light, or additive color mixing, the three primary colors are blue, green, and red. Computer monitors and both cathode ray tube, CRT, and flat panel television sets use these colors. The combination of these primary colors results in other colors. And when all three colors are combined with equal intensity, white is formed.
What are other examples of impulse and change of momentum?
If you catch a baseball or softball, especially without a mitt, you know that you move your hand in the direction the ball is moving. You certainly don't move it toward the moving ball. In stopping the ball, its change in momentum is the same, no matter how you catch it. Thus the impulse your hand gives the ball is also the same. What changes? When you move your hand in the direction of the ball, you increase the time. The force of your hand acts on the ball. That means that the force is less.
What is a tsunami?
Series of waves in water caused by underwater earthquakes and volcanic eruptions.
What is an ultrasonic sound?
Frequencies above human hearing, 20 kHz.
What is the centrifugal force?
A pseudo-force that exists only in rotating reference frames. Apparent force outward from center of rotation.
What are the types of waves?
Transverse and longitudinal waves are two major forms of waves. A transverse wave can be created by shaking a string or rope up and down. Although the string moves up and down, the wave itself and its energy moves away from the source, perpendicular to the direction of the oscillations. The oscillations in longitudinal waves move in the same direction that the wave is moving. The medium in longitudinal waves alternately pushes close together, compression, and separates from each other, rarefaction. The best example of longitudinal waves are sound waves, which are a series of back and forth longitudinal oscillations of atoms or molecules that form alternate regions of high and low pressure in a medium such as air. Water waves are a combination of transverse and longitudinal waves that move in circles. Just as in the case of transverse and longitudinal waves, energy is transferred but matter is not moved.
Does the total energy of a system ever change?
No. Think about a block of wood on a table. You push it, doing work on the block and transferring energy from your body to the block. The block starts moving, but quickly slows and comes to a stop.
In what ways do atoms emit and absorb light?
In the mid-1800s, Robert Kirchhoff published 3 laws that describe how materials emit and absorb light. 1. A hot solid or a hot, dense gas produces a continuous spectrum. 2. A hot, low-density gas produces an emission line spectrum. 3. A continuous spectrum source viewed through a cool, low-density gas produces an absorption line spectrum.
What is a diffuse reflection?
Light rays reflect into different, random directions, as from paper.
Who was the first person to explain how rainbows are formed?
Newton was not the first person to understand the optical characteristics of a rainbow. In fact, it was a German monk in the early 14th century who first discovered that light refracted and reflected inside a water droplet. To demonstrate his hypothesis, the monk filled a sphere with water, sent a ray of sunlight through the sphere, and observed the separation of the white light into colors along with the reflection on the back of the water droplet.
What happens when a magnet is cut in two pieces?
When a magnet is cut, the atoms within the domains remain aligned. In almost every case, the cut would be between two domains, leaving aligned domains in the two halves. If you cut a domain, you would create two smaller domains, each with a north pole and a south pole. So no matter where you cut, the result is two magnets, each with its own north and south pole. The more domains, the stronger the magnet.
What is a torsional wave?
Material is not only displaced vertically, but also twists in a wave-like fashion.
What is a wavelength?
The distance from one point on the wave to the next identical point, the length of the wave.
What is an alpha decay?
Type of radioactive decay where nucleus emits an alpha particle. Result is nucleus with atomic number reduced by 2 and mass number reduced by 4.
How can that be?
Even though the nails have very tiny tips and would certainly penetrate the skin if there were only one. Because there are dozens of nails in the bed. The person's weight is distributed over many nails, and the force of each nail is quite small. The pressure is not enough to penetrate the skin. Anyone doing this demonstration has to take precautions. The parts of the body not on the lower bed have to be supported at the height of the nails. If the concrete block is broken, the person must wear safety goggles. And a sheet of wood should be held to keep any concrete from flying into the person's face.
What is radiation?
A means of heat transfer when infrared waves are emitted by hotter objects and absorbed by colder ones.
What is an electromagnetic wave, M?
Two coupled transverse waves, one an oscillating electric field. The other a corresponding magnetic field perpendicular to it and perpendicular to motion of wave.
What is the third law of thermodynamics?
The third law of thermodynamics states that absolute zero, the lowest possible temperature, can never be reached. The entropy of a system is zero at absolute zero. A procedure can remove a portion of the entropy, but not all of it. Thus it would take an infinite number of repetitions of the procedure to reach absolute zero. It's been possible to achieve temperatures as low as a few billionth of a Kelvin. But it has never been able to reach absolute zero.
What is a lepton?
Lightweight particles like electrons and neutrinos.
What is a cone?
Cone-shaped nerve cells on the retina that can distinguish fine details in images. Located predominantly around the center of the retina called the fovea, responsible for color vision.
What is the standard time?
The cesium-133 atomic clock is the standard for the second.
Where did the term horsepower originate?
The term horsepower came from Scottish inventor James Watt. The value for a unit of horsepower was determined after Watt made an extensive study of horses pulling coal. He originally determined that the average horse was able to lift 33,000 pounds of coal 1 foot in 1 minute. The conversion between watts and horsepower, HP, is that 1 HP equals 746 W equals 0.746 kilowatts. In the United States, automobile engines are rated in horsepower, while in the rest of the world kilowatts are used. In a hybrid car, the power of the gasoline engine is usually measured in HP, while the electric motor is measured in kW.
What is plasma?
State of matter consisting of electrically charged particles.
What is the string theory?
Proposed theory to replace the standard model. Each particle is a string, a tiny closed loop. Requires a 10-dimensional space-time rather than the normal 4-dimensional one.
Why is it dangerous to look at a solar eclipse?
Looking directly at the photosphere of the Sun, the bright disk of the Sun itself, even for just a few seconds, can cause permanent damage to the retina of the eye. because of the intense visible and ultraviolet rays that the photosphere emits. This damage can result in permanent impairment of vision, up to and including blindness. The retina has no sensitivity to pain, and the effects of retinal damage may not appear for hours. So there is no warning that injury is occurring. Under normal conditions, the sun is so bright that it is difficult to stare at it directly. So there is no tendency to look at it in a way that might damage the eye. During a total eclipse, however, with the sun covered, it is easier and more tempting to stare at it. Unfortunately, looking at the sun during an eclipse is dangerous even if totality occurs only briefly. Viewing the sun's disk through sunglasses or any kind of optical aid, binoculars, a telescope, or even an optical camera viewfinder, is extremely hazardous. The best methods are to use special solar filters, welder's glasses, or a pinhole camera.
What is a calorie, cal?
A unit of energy that is used both to measure both thermal energy and heat.
What is a very large array, VLA?
Group of 27 radio telescopes spaced as much as 13 miles apart from each other in Socorro, New Mexico.
What is a first-class lever?
Simple machine with pivot at one end or bar. The input force applied at the other end, the effort force between the two. Ma greater than 1.
What would happen if the same ball rolled off a table?
To answer this question you should define a coordinate system. One axis points down, the other, perpendicular to the first. Points in the horizontal direction of the rolling ball. The force of gravity acts in the downward direction, causing the ball to accelerate downward. But there is no force in the horizontal direction, so the ball's horizontal speed would not change. Because only the downward acceleration affects its fall. It would hit the ground at the same time that a dropped ball would. The path the ball takes is a parabola. Galileo's principle of relativity, not Einstein's, can help you understand this result. Galileo imagined a sailor dropping a ball from a high mast on a moving sailboat. The sailor would see the ball drop straight down. But an observer on the shore would see the ball having a horizontal velocity equal to the velocity of the boat. Therefore this observer would see the ball's parabolic path. But both would agree when the ball hit the deck of the boat at the same time. Galileo said that the laws of physics are independent of relative motion. This statement is called the principle of relativity.
What is an image, light?
Point at which light rays converge.
What is terminal velocity?
Constant velocity attained by a falling object affected by drag in a gas or liquid.
How were the first mirrors made?
People have seen their reflections in water for hundreds of centuries. But some of the earliest signs of human-made brass and bronze mirrors have been mentioned in the Bible and in ancient Egyptian, Greek, and Roman literature. The earliest glass mirrors, backed with shiny metal, appeared in Italy during the 14th century. The original process for creating a glass mirror was to coat one side of glass with mercury and polished tinfoil. The German chemist Justus von Liebig, 1803–1873, in 1835 developed a method for silvering a mirror. His process consisted of pouring a compound containing ammonia and silver onto the back of the glass. Formaldehyde removed the ammonia, leaving a shiny metallic silver surface that reflected the light. Today, most mirrors are made by evaporating metallic aluminium directly on the glass.
What happens when light hits a sheet of paper?
Replace the mirror with a sheet of paper. Darken the room. Aim the flashlight at the paper and use a second sheet to catch the reflection. You'll see that the second sheet is illuminated in many different locations. The light is reflected from the paper, but into many directions. This kind of reflection is called diffuse reflection. Polished, smooth surfaces that do not absorb light are the best reflectors. Examples of reflective materials are shiny metals, whereas non-reflective materials are dull metals, wood, and stone.
What is a difference tone?
Frequencies produced as a result of two different frequencies mixing with each other.
What is Newton's third law?
When two objects, A and B, interact, the force of A on B is equal in magnitude but opposite in direction of the force of B on A.
What is thermodynamics?
Thermodynamics is the field of physics that studies changes in thermal energy and the relationship between energy, heat, and work. The field of thermodynamics was developed when people sought to increase the efficiency of early steam engines. There are 4 laws of thermodynamics, which for reasons of history are numbered 0 through 3 rather than 1 through 4.
What is a spectrum, absorption line?
Continuous spectrum with dark gaps produced by a continuous spectrum source viewed through a cool, low-density gas.
What is an antenna?
Used to transmit or receive electromagnetic radio waves.
What is the dark energy?
Said to be cause of accelerating expansion of universe. Comprises 72% of mass and energy of universe. Its nature is totally unknown.
What major discovery did Archimedes make in the 3rd century BCE and how did he apply it?
Archimedes, c. 287 c. 212 BCE, lived in the city of Syracuse on the island of Sicily, then part of Greece. He was charged by the king of Sicily to find out if his crown was made out of pure gold or an alloy of gold and silver. Archimedes had to do this without destroying the crown. One day, when bathing in the public baths, he noticed that when he stepped into the bath the water rose. He had seen this many times before. But this time he recognized that this common occurrence could help him solve his problem. Legend has it that he was so excited that he ran naked through the streets of Syracuse, shouting "Eureka!" or "I have found the answer." He then did experiments where he hung the crown on one end of a balance and a piece of first gold and then silver from on the other end. When the weight of the crown and that of the metal were equal, the balance was horizontal. He then immersed the balance in water. If the crown and the metal had different volumes, the water they displaced would be different and the balance would tip. He found that the balance tipped when both the silver and gold pieces were on the balance. Archimedes had found that the crown was not pure gold, but a mixture of silver and gold. The king had been cheated. Archimedes had discovered a principle of hydrostatics, liquids at rest, that would one day carry his name. Archimedes' principle states that an object immersed in a fluid will experience a buoyant force equal to the weight of the displaced fluid. A huge steel ship like an aircraft carrier can float instead of sink like a stone, because it can displace enough water to compensate for its weight and because the air inside of the ship makes its density actually less than the water around it.
What is ferromagnetic?
Iron, nickel, and cobalt. Unpaired electrons in large groups of atoms interact with each other so that they point in the same direction. Strongly attracted by magnetic fields.
What is latent heat of fusion?
Energy involved in change from solid to liquid phase.
What is a hue?
Related to the wavelength of a color.
What is quantum mechanics?
The field of study of atoms by themselves, as well as in molecules, liquids, and solids in which the wave nature is important is called quantum mechanics. The atoms obey the Schrödinger equation. But for any atom more complicated than hydrogen, the equation can be solved only by a computer. Using computers to solve equations, run complicated models, and simulate experiments is an important subdivision of the study of physics called computational physics, which now has equal status with theoretical and experimental physics. Some of the recent accomplishments of quantum mechanics are in the areas of condensed matter physics, or the study of solids, and atomic physics. All of the integrated circuits used in MP3 players, televisions, cameras, and automobiles are designed using quantum mechanics. They are all based on diodes and transistors, where quantum mechanics describes and explains their properties and guides materials scientists to select appropriate materials for their construction. One of the most exciting new materials is graphene, a film of carbon where the atoms are in hexagon-shaped arrays, but the film is only 1 atom thick. Graphene is being investigated as a way of constructing extremely tiny transistors, and thus powerful integrated circuits. It may also be used as a sensor to detect single atoms or molecules of selected materials, or as a transparent conductor for touch-screen computer displays. Its discoverers won the 2010 Nobel Prize. From 1924 to 1925, Einstein and the Indian physicist Satyendranath Bose. 1894 to 1974, predicted that if an atomic gas were cooled enough, the atoms could form a new state of matter that would exhibit quantum effects on a macroscopic scale. The first experimental confirmation of this prediction occurred in 1995 when Eric Cornell, 1962, and Carl Wieman, 1952, at the University of Colorado cooled a gas of rubidium atoms to about 1/6 of a millionth of a Kelvin. They and Wolfgang Ketterle, 1957, at MIT shared the 2001 Nobel Prize for their work. while this new state of matter, called a Bose-Einstein condensate, has no existing applications. Physicists are using it to improve their knowledge of how atoms interact at very low temperatures and to explore possible future applications to atomic clocks and computers.
What is a lumen, lum?
Unit of measurement of luminous power.
What is condensed matter physics?
Studies the physical and electrical properties of solid materials.
If the low-wavelength light is scattered, why do we only see a blue sky and not a blue, indigo, and violet sky?
Lord Rayleigh, John Strutt, 1842–1919, determined that the nitrogen and oxygen molecules in the atmosphere scattered sunlight, allowing us to see the sky. The scattering is strongest at the lowest wavelengths.
What is a current, electrical?
The flow of electric charge.
What is conservation of energy?
The energy of the system doesn't change, energy is neither created nor destroyed. The energy put into a system equals the energy change in the system plus the energy leaving the system. True as long as no objects are added to or removed from a system, and as long as there are no interactions between the system and the rest of the world.